This episode is sponsored by United Refrigeration and Westermeyer Industries, revolutionizing your HVACR experience. Visit URI.com for all your HVACR needs, offering real-time inventory, personalized pricing, and a nearby stock feature. Access quick pick replacement parts and branch details effortlessly. With 350 plus fully stocked locations across North America, our knowledgeable staff are ready to assist with the solutions you need. Exclusive offer. Use code ARPOD on URI.com to get a $10 gift card when purchasing the Westermeyer oil float, part number W4300-38F. These high-performance floats are not just compatible with their own oil separators, but also available as a crossover model, conveniently stocked at United Refrigeration. That's code ARPOD to claim your $10 gift card. Visit URI.com now.
The Sporlan division of Parker Hannifin Corporation is sponsoring this podcast. Sporlan is the leading manufacturer of HVAC and R components. Using quality materials and craftsmanship, Sporlan maintains a commitment to innovation, manufacturing excellence, service, and support for its customers since 1934. The company is known for its catch-all filter dryers, thermostatic expansion valves, solenoid valves, pressure regulating valves, suction filters, electric valves, controllers, supermarket monitoring solutions, chemicals, smart service tools, Zoom Lock Max, press to connect, and Zoom Lock Push to connect refrigerant fittings. If folks want to learn more, what do they do?
You can go to sporlan.com.
I guess that's Jim and John for Sporlan signing off.
I know they get bad. That's why they just sit there and they never see the light of day. Actually, one day I got to just sit down and basically just record a best of Kevin, or hey, we didn't release this because there's so many expletives. Like when I used to try to use the button. Good evening, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. How'd your job today go?
Oh, I'm exhausted. Got my ass absolutely handed to me by an E3.
Why?
Trying to replace it and trying to figure out how to get all these ADF files in there and all these license keys. So it's not like the E2 where it's like super simple, easy. It's a lot more steps to it. And then trying to figure this all out. I had never done it before and I got zero instructions on how to do it. So So that was fun. And then I left and then all the CC200s wouldn't come back online, even though everybody said they would. So I had to make a few phone my friend calls and get them to fix the CC200s, whatever they did.
Yeah.
It's witchcraft.
Did you have to use the CAC? Call Canadian?
No, this was called a Georgian.
Oh, Georgian. Gotcha.
Yeah, this was, the Canadian was busy.
Damn it.
So
what's he doing all day?
I'm pretty sure he's in the U.S.
I know, I'm just kidding.
He definitely saved my ass this morning, though, when the E2 showed up as the wrong version. Just so you guys know, the CO2 E3 is different than a normal E3.
That it is. It needs a whole bunch of other files in it, doesn't it?
Yes. And you have to put the description file in before the license.
Description before license. All right, just remember that because it's alphabetical.
Yeah, it's I was doing it the other way, the way I usually do the E2. It's usually license before description file.
Is there no instruction somewhere that somewhere has? Where
I couldn't find them. I was so irritated and frustrated at this point. So my E3, the screen went dead. And we ended up taking a site supervisor tablet and putting it into port 2 on there.
Mm-hmm.
So you could see the E3. And it worked good. But it was either that or leave my laptop up there, and I really didn't want to leave my laptop up there.
Is that the one with the line in it that has a?
Yeah, now it's a line in the center, and then it's got like a giant spot in the center also. So like anything in the middle, like I can't see. If only I could.
I don't know how you have so many problems with computers. I have no idea.
That thing is clapped, done. Like we do a podcast out of town, and it's miserable.
Oh, I know. Last time it wasn't really cooperating.
It's so slow. It is so slow. And then I'll buy a brand new computer with a solid state drive. It'll be the slowest freaking computer ever.
It's because you're cheap.
I'm not cheap. I bought a nice computer this time.
Yeah. Debatable. Very debatable.
Pause it for a second.
Well, they're still barking, so I know they're alive.
Yeah, they're in the backyard. I'm sure my wife just screamed at some guy who's doing door-to-door sales.
Yeah, we get that all the time here whenever we have storms. Like whenever we have a hailstorm, literally for the next 2 weeks, it's nothing but roofers just pawning their goods up and down the old walkway.
Yeah, I live in the middle of nowhere, so there shouldn't be anybody anywhere.
Yeah.
There's 5 houses over here, 10 houses, so there shouldn't be people walking up and down the street.
But there was.
Yeah, so
That's dumb. So besides your fighting battle with the E3, what else are you up to?
this week has been absolute utter chaos. I'm trying to finish all these. What?
It's always absolute utter chaos. Like
it is.
If we played the first 5 minutes of every podcast, how's your week? Utter chaos. Just a shit show.
Shit show. Like now, there was that time for a month we were like super slow. There was just super duper boring. But no, this has been like a pain. These OSHA sensors that this never-ending nightmare that change every week.
It was putting in sensors. How bad could it be?
Oh my god, it's turned so bad. Like the locations have changed, the sensor types have changed, the getting it all in and now getting it programmed on 3 different control systems and trying to keep it all straight where everything got done. And yeah, so it's that, and then we are just like way behind on stuff up here.
Really?
So I had a condenser yesterday. We put it in December. Break 6 out of the 10 motors shafts cracked.
Yeah. Let's talk about that because, like, I saw actually today. I was perusing Facebook. All I was looking for was I noticed in all my pictures. I always take pictures of stuff that's broken, but I never take pictures of what it looks like when it's not broken. I know what it looks like when it's not broken, so I don't need to take that picture. So now that I'm making all these training decks, I'm like, I need a picture of a nozzle of an expansion valve that's feeding properly. Out of all the pictures that I have, nothing, not a damn thing. So I just sent an mass email. I was like, hey, does anyone have any pictures while they're out on site? But yeah,
I had a good one. So I was at a Schmamazon. And
after that, I want you to continue talking about your other thing.
We'll do condensers first.
Yeah, let's talk about
it broke 5 out of 10 shafts. And they actually slid down on the shafts. It wasn't that they completely cracked. They slid down on the keyways. And the set screw for all the keyways came loose. Now, these were Loctited from the factory.
Wow.
And the rear screw was tight, like to the point where I couldn't get it off without a decent sized crescent wrench.
Wow.
So they weren't loose.
Mm-hmm.
And it was, every single one of them was broke. I started looking. This is an EnviroGuard rack.
Oh, no.
And the store tech said that his head pressure wasn't high enough in the wintertime, so he couldn't keep the rack running. So he upped it to 85 degrees.
85 degrees. Saturated condenser?
Yes. On a massively oversized condenser. Went from a 2-fan belt drive to a 10-fan horse and a half 1140 motor condenser. And then he set the TD or the basically with the throttle range and Danfoss, the neutral zone, to 7 on fixed speed motors.
So is this doing pressure or heat?
Saturation, but like 7 degrees is pretty damn tight.
It's aggressive. It's aggressive. No, hold on.
No VFD.
Oh, okay. Then never mind. That's aggressive as hell.
That's super aggressive.
Yeah.
So the only motors that broke were the middle motors. The header fan motors were probably always on, almost. And the electrical motors have like almost no runtime. So it was only the motors in the middle that broke the shafts.
So it was overcycling like hell.
Oh, yeah. Thousands of cycles. And then, of course, they wanted us to warranty it. So we ended up getting them warranted. But, yeah, thousands of cycles until it broke the motors. So this, again, one little set point change, like 2 little set point changes like that can drastically affect something. So it's one thing, and there was nothing wrong with it running a 50-degree condensing temp.
What do you mean? That's way too low, especially if you're 20 degrees saturated. Like what? Oh, wait, the subcooling. You're going to get a shit ton of subcooling, so that's fine.
Yeah, it's one of those things that in-house tech knows better. So
wait, at Schlemzon,
this wasn't a Schmamazon. This was a store up here. So this is where the broken condensers were. So at the Schmamazon, I was there. We're restarting the store, and
okay.
I was helping my other startup guy. They threw some coils. We've never been here before. We took some cases out, shut down the store, took some cases out, put some new cases in, went to go fire the racks back up. Another contractor did it like 2 years ago. It's been sitting dead for a year. Goes to fire the racks back up, and there's just a plethora of issues. Leaks in the lines, comm lines just not done right.
Mm-hmm.
Everything's just messed up. So he goes to the produce coils, and all the coils are burned out for the pulse valves. So nobody thinks nothing of it. They figured they left them on.
Wait, all of them?
All of them in the produce cooler. All 3.
Wow.
So he throws 3 coils on it, starts it up. They burn out the next day.
Mm-hmm.
So everybody's figuring the valves are messed up. 2-year-old store. I go there. I go to look at the first one. I'm like, something's not right here.
Mm-hmm.
Produce coil, 208 coils for the fans, 110 volts for the pulse valves. I look at the coils and they're melted. I'm like, something's not right. I pull the first coil off. It's got 210 volts at it. I'm like, the hell? Go over to the XM. It's 115 volts.
Okay.
Look at the fan. Shut the fan off. 89 volts.
What?
Turn the fan back on. 210 volts. I look at the fan. I'm like, they're going decent speed. Like I look at it. I'm like, 115 volts. Like looking around. I'm like, white wire is leaving the XM. White wires on the fan motors. I'm looking. They crossed the neutral and the hot for L1 of the fans in the pulse valve. On every coil.
So the coils were getting what?
110 volts, and they were still running. They were 208 volt motors.
Oh.
They were still running, and the pulse valve was getting 208 volts. So it melted them all.
Awesome.
So this has been like this since startup 2 years ago. This store was open for 6 months. Nothing has changed with the produce.
That's freaking nuts. That's ridiculous.
This is my theory. When the box came down to temp,
mm-hmm.
It started stepping them, and it was 6 seconds on, 6 seconds off. So it wasn't enough probably to burn the coil up.
Ooh.
But when the fan stopped, the coil would shut off. But the coils were, the fans were running at decently full speed.
That's amazing.
Yep. I'm sitting there, I'm like looking, I'm like, oh God, how many other coils are like this?
All of them.
I'm sure the more we looked at this store, the more we found like just tons of stuff not set up right. Somebody installed a bunch of EPRs all over the store in stepper valves.
Mm-hmm.
Instead of using the like a pressure association, like hundreds of transducers. Every system has its own transducer. They mix the racks up, so there's like stuff on A rack, on B rack, controlling it, so you have no idea. It's just all messed up.
Sounds awesome.
It's a little bit of a science project. What about you?
I've been doing nothing but sitting in front of my computer and making training decks. I spent like an hour and a half on the phone this morning with the guy that Danish guy that I think he's Danish, either Danish or German, the gentleman that created the green chill rack, and was asking him a whole bunch of questions because I'm trying to make training for the carrier rack that doesn't have an oil sup. And so that's what I did today. Trying to think if anyone called me this week. It's been, believe it or not, it's been fairly quiet.
The whole upper Midwest is burning right now.
It's still 100 degrees down here in a good old Texas. But actually, you know what? I do have something to show. Hold on. So I'm going to start from the beginning. So he's sending me pictures of first the model and serial number. Hold on, let me bring this up. Share. Entire screen. So he gives me these cases, ONRZH4. And I'm just asking him for a multitude of pictures just to see if I can find anything out of the ordinary. And nothing. Wow, that's weird. I was looking to see if there was anything going on crazy in there because I was like, sometimes the cases get swapped between liquid and suction, whatever. Nothing. There's no distributor. So it's just one of those in and out coils. So like I saw that at first and I was like, wait a minute, is there a distributor? And he's like, oh, okay. I was like, cool. So he took a picture of this. I wanted to see how they were piped, see how the liquid is going in, how the suction was going in. But yet the case was just not really pulling down the temperature. So going through, this is him taking pictures of this to make sure everything's straight. The only thing that was odd that it goes down the case was at 3/8 and then jumps up to it's at 1/2 inch, 5/8 or something right there. And still, it was just eating shit and just wasn't working. Made sure, oh, no, different picture. So anyway, long story short,
I was like, I know what it is.
What were we gonna say it was?
When that plug, I seen that dryer all like that. I'm like, oh.
No, it wasn't. No, that was something else. No, because this was a CO2 rack. This is a CO2 rack. So if you have, you really wouldn't have ice on there. But no, that wasn't it. But this is actually what the problem was. During refrigeration, you see how the controller's in refrigeration? He was getting defrost power.
Hell yeah, dehumidification.
So the case was really dry. Just wouldn't pull down the temperature at all. He's like, I didn't hear back from him for a while, and I know why, because I'm such a freaking dummy. I've been looking at this case forever. I was like, why? What'd you find? He's like, freaking heater's on. I'm like, oh, because you really don't think about that. You know what I mean? Like, are you really gonna? How many times have you checked to see if a heater was on during defrost? I'm sorry. How many times have you checked for a heater to be on during refrigeration?
Quite a bit, because I see it a decent amount.
Okay.
I've seen. Is that a Corel controller or is that a Danfoss controller?
Danfoss.
I'm very particular to microthermal now, especially when it comes to CO2. It just works.
I got nothing because anything I say, I'm gonna have to edit out anyway. So
they're not going to sponsor the podcast anyway.
I wasn't talking about that. It's just when we met up with them, we were like, hey, it would be really cool to have some of your stuff.
There's an 800A sitting right there. It has no power. Yeah. That one fell down a flight of stairs, though.
I thought, oh, that's the one that fell down?
Yeah.
See, that's a good. I just thought of something awesome.
What? I did not kick it like you guys all said. I got close. That one fell down a flight of stairs. It ran the rack for like a month.
So anyway, what else have you been going on this week?
Other than that, I am just running around like a chick with my head cut off, trying to fix stuff and get to all these sites so we can clean this stuff up because we have a million control changeouts to do, and we have nobody to do them right now.
What kind of changeouts?
Danfoss to CBC to Danfoss, and then microthermal or CPC to microthermal.
Really?
Yeah.
That'd be fun.
The CPC to microthermal ones are way more fun. The Danfoss ones make me want to jump off a cliff. So much more work.
Why? Why do you say that?
Because all the sensors got to get changed, all the transistors got to get changed, all the extra workarounds.
If you just let other people do the other stuff, you could do the more complicated stuff, and then you wouldn't have to do the stuff that you don't want to do.
Today's episode is sponsored by the RefraShield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
Gee, thanks for the English there. It made no sense. So what are we talking about tonight?
I don't know. I have no idea.
Bring up that CO2 sizing thing.
You know what? I was going to play with that, and I didn't even get a chance to because I keep getting errors. So let me start basic then. See if we can figure this thing out, because I couldn't figure out what dimension. It would probably help if I shared.
Well, let's go over some like basic CO2 sizing.
Yeah, I know. I'm just going. Okay, hold on. Okay, so two-stage transcritical. So this is what I couldn't figure out. This was the dimensioning capacity. I don't know what that means. I don't know what dimensioning capacity means. Because every time like I try to size something, so I have 100,000 BTUs here, and then on the low temp I have 25,000 here. And then so on this software, you have your heat exchangers and all this other information, right? Same thing with the discharge side. But I calculated it for what Satan's temperature would be out in Fort Worth. And when I hit calculate, we'll see what happens. It actually, based off the temperatures, it's actually pretty rad. What it'll do is it'll figure out the energy consumption depending on what compressors that it picks. But then if I have anything messed up or I didn't size something properly, it yells at me and gives me a warning. And then I got to try.
Can you change what compressors you pick? Can you do Bitzers? Can you do Koblenz?
So here, look at this. So cooling capacity right here, it's going to yell at me. So in July at 2 and 3 o'clock on the 7th, it's telling me that its cooling capacity is working outside of its capacity. You need more capacity. And then outside envelope calculation outside of its envelope for low temp. So like I said, I haven't figured out how to do that yet. I wasn't too sure that I wanted to do this because I haven't been able to figure out. So I still haven't read through the whole manual. So go to the air. All right. Capacity is too small. So I don't know what capacity they're looking for here. So it's ambient temperature. So if I don't know, let's just do 80 degrees. Because the software is fairly complicated. Like I just have never used it before. So I'm trying to end up figuring out, I don't know, 15,000. Or did I do 10,000 for the other one? I think I did 25,000. I'm not sure. 15,000. 15,000. Because I don't.
What is the 1, 2, 3, 4 at the top? Is that
rating points input? Hold on. Let me just guesstimate here. 75,000. 75,000. Right. Put me on the spot here. I was just figuring out how to mess with this. Okay, so then if I hit calculate, it brings up the pH. Oh, there we go. I got it to work that time. See, what I don't know is when you go back to system setup here, when you go, where was it? like somewhere it was system setup. Hold on, add system configuration. So here you can, so I don't know what dimension and capacity is. That's where I'm struggling here. Are you looking up dimension capacity or?
No, I was
texting. You're a jerk. So anyway, so you can look, you can select compressors from the database. So you can do Bitzers, you can do Bach, you can do Copeland, Doreen, Faz Cold, or
say that again. Doreen.
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 Dorn.
Doreen.
Dick. So there we go. Blah, 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 blah. So then, oh, the only thing I didn't do is select the American 60 hertz. And then, so I did that.
Keep that 50 hertz shit out of here.
Yeah. So then we'll do speed control. Let's do, I don't know, four compressors. Yeah, because that's going to be a big compressor. And then compressor type, it doesn't really matter. I'll just keep it like that. Evaporation temperature, I'm going to bump that up to, what's typical, 18 degrees.
20, or you don't want to run it at 10 like some of these rack manufacturers, or like 14 with 28-degree cases.
They're using the software then. All right, so then if we go over to here, select database. So I'm going to do minus 22. This is typically what we use in Merca. TC, fixed discharge superheat. I'm assuming that this would be my
transcritical.
I don't know. I don't know what the TC is. I'd think that would be my flash tank. No,
maybe?
Yeah, because T condensing, maybe T, because TE is suction.
Get info down the bottom.
Oh, I didn't see that. It doesn't work.
Well, I'm going to say that's probably flash tank, so put it at 33. See what it does.
Okay. We'll learn together. All right, and then when I hit OK, and then auto generate. Yeah, that makes sense, because look, 33, and then minus 22. Okay, and then we'll just put 3 compressors on there. Screw it. Yeah, dimension and condensing temperature. That's what it is. Ha. Just
what is it?
Dimensioning condensing temperature.
Oh,
I need to read the manual. I haven't read the manual yet. I just started playing with this today.
Read the manuals.
Oh God. All right.
You're from Texas.
What the hell does that mean? I know how to read. I'm not even from Texas.
Yeah, you've been assimilated.
I don't have any debt.
You probably can't have any. Probably got to live there for 20 years to make sure you're not one of those people.
It's such a dick.
Came from liberal land.
By the way, if anyone wants to know what that sound is, it's Kevin usually drinking his gallon of water.
Dude, stop it. Dude, does it show you which compressors that it chooses though?
No, because I think it just randomly picked whatever, because we didn't specify which ones we actually.
Yeah, but does it show you like what compressor it's going to choose?
I just started playing with this, so I don't know. Okay.
I expected much more out of you.
I was busy working today. Our warning, low temp is only fulfilled 92% of the time. Yeah, so what? Total load is only fulfilled 92% of the time. Increased compressor capacity or decreased load. Yeah, whatever. Okay. Conditions, economy report, ratings. Here we go. If I do calculate. So yeah, that worked. I got warnings. I got to fix the warnings, but it gives you the gas cooler profile. I still don't know what that is. I'm not an engineer. I haven't figured that out. But yeah, so if you click on here, rating outside of its envelope. So that's no good. So calculation outside of its envelope. TE minus 22 and T condensing temperature 33.
So it's saying it's too high
of a suction pressure, but that doesn't make any sense if it's a low temp compressor, right?
No.
We
definitely got some more planning to do with this, but it seems like you could probably backwards engineer a lot of these racks, because like we're starting to get to remodel territory with a lot of these stores, and like they're saying there's not enough capacity on them, and it's the opposite. We got way more capacity than we need.
Really? See, look at even if I knew how much electricity costs, I could essentially figure out what the cost would be, right? As far as consumption and CO2 equivalent emissions minus the reliefing, you know. But yeah, like I said, I haven't had enough time to play around with it. But what was really cool, like why I ended up getting this, is so you can do 1-stage, 2-stage transcritical, 1-stage transcritical with ejectors, 1-stage transcritical parallel compression, 1-stage transcritical ejector parallel compression, and then 2 1-stage common condenser. So I'm assuming that's probably like a subcritical system. And then you could actually tell it if you could actually make that part of the system flooded evaporators if you really see fit. And the same thing with the cascade. You have cascade transcritical and then cascade CO2, which I don't know what that means. I haven't played with that one yet. And then you have all these 2-stage options. So you have the intercooler, closed intercooler, 2-stage transcritical parallel compression, 2-stage transcritical ejector, PC.
Hey, off to the side, does it give you a compressor model?
On this?
Yeah.
Let's hear. So I can go like this. No.
Switch it from generic, switch it to recips.
Yeah, so we can pick one of these compressors then.
Pick a Copeland.
So you can pick one of these tree.
It's all they have is 3.
I don't know why that's it.
Go to Bitzer, see what they got.
Oh, here, let's. Oh, okay, you can add all these compressors. Okay. So you can pick, well, here, let's see, like VariSpeed. Let's throw a VariSpeed on there. And then a regular Econoline.
Holy shit, they got a lot more compressors in here. Would they pay for this?
No, but it's I believe it's a Danish software. Let's see. I'm gonna see how many Bach compressors there are. Let's see.
270.
Holy crap! And a cracker.
So I think you could do the same thing with the Copeland software.
It doesn't have as many options. See, because the reason why I ended up purchasing this today is because I've gotten down this ejector rabbit hole, and I wanted to know more things, and I didn't have, I didn't know. So I was looking for something that had ejectors. So I started with the Copeland software. Danfoss has some stuff on their cool selector, but not as much as this software.
I'm just not sold on the ejectors yet.
So I've done my research. People are hit and miss because it's always robbing Peter to pay Paul, right? Because ejectors the way ejectors work is you're stealing medium temp capacity from the compressor, from the cases, so the compressors don't have to use it. But in order to utilize the most efficiency out of it,
you need a head pressure high as shit.
The head pressure needs to be higher. Yeah. Okay. So yeah, you're sucking some load off of your cases, but you're having to raise your head pressure above normal. So like some of the carrier stuff, they have 2 different types of systems. They have one where like I showed last week, where the ejector is either working as an HPV solely, or the ejector is working as an ejector. But the thing is with that, they had said when we were in the training that they typically don't use adiabatic on there because they want that high TD so they can utilize that higher pressure in order to get more efficiency out of the ejectors.
Yeah, but I don't think the efficiency runs via just losing that. Just switching from transcritical to subcritical is a lot more flash gas. So are you really doing anything, or are you just pissing in the wind?
I mean, if 3% is 3%, that's still 3% savings, right?
I think 100% the number one missed thing is geothermal. Sold on it.
Now you do.
Yeah, it was 98 today, or it was yesterday. It was 98.
Yeah.
We only hit 820 pounds of head pressure.
Really?
Yep.
And it's been hot in Chicago for quite a while, has it not?
Yeah, it's going to be 90s for a month, so the whole place is going to burn. Maybe a cow tip over a lantern again.
Wait, what?
Yeah, that's how Chicago burned back in the day.
Explain. I've never heard that.
You never heard about the Great Chicago Fire where the whole city burned?
Yeah, but why are you saying about a cow?
That's how it happened. A cow kicked over an open flame lantern and lit a barn on fire at the edge of the city and just ripped through the city.
I think you're bullshitting me now.
I'm serious as could be. You can Google it.
I'm not going to Google it now.
This is interesting because it's actually pointing out like your BTU usage. So I wonder if you could size it to having 2 variable speeds.
Yes, I believe you can. Let's see. All right, let's see what it does now. So economy report.
Because the last rack I just started up, 2 variable speeds, that is money. A small variable speed and a medium-sized variable speed, that handles so much of the load together. Almost cuts cycling down to nothing.
So this is what I got to figure out. So deliverable cooling capacity. So like what you said about reverse engineering, I think that's what I'm going to have to end up doing, is figuring out what this is. So what I'm going to do is take one of the racks that I have a reefer schedule for, and then input the data that's in there, and see if I can simulate what it's doing.
Delivered refrigeration capacity, I would think would be
cases, right?
It'd be your case compressor load, like you would normally see it. Then the rest is going to be your heat of rejection.
Yes.
But does it spit out a compressor model? That's what I'm most interested in.
Well, no, I basically selected it when we were at system setup. When we came over here, you
told it a BAC or whatever, but does it tell you which one is best for compressor 1, which one is best for compressor 2?
Oh, I don't think so. But you can hold on, auto speed control. See, that's auto select, and then select compressors from database. So so I literally selected every single one of these. But yeah, you can. Look what I did. External drive. I just selected external drives. I'm Oprah here. You get an external drive. You get an external drive.
I'm building one expensive rack here. But it'd be super interesting if it spit out the compressor models for you, because then you'd be able to do a little bit more engineering or backwoods engineering here. Because a lot of these, I was looking at some Hill stores the other day, and they're pretty much identical stores. The racks are pretty much cookie cutter, but the BTUs are all different.
Yeah. So here, select compressors from database. So I think that's what. Let's see. This is. I think based off of the capacity. Hold on. Show. Oh, here. Yeah. So watch this. So show only compressors within the capacity. No, that's not it. So I guess I'd have to figure out which ones I'm doing, right? Based off the capacity. Drive loss. See, that's what you get for rushing me here. We can play around with the software, see what we can get. Oh, transcritical and non-transcritical compressors cannot be on the same pack. Sorry. But yeah, it looks like you can basically select multiple compressors with external drives.
That's interesting. It'd be a little bit cooler if it actually put it all together for you.
I haven't gotten that far. So here, let's calculate again. See what it'll do. Stop texting. Damn it. Who you texting? Is it Zach?
No, it's not your business. I'll text Zach to mess with you because he loves poking at you.
Poke bear.
This is probably the one person you can't figure out, and it's fucking great.
Oh no, I have now. Don't freeze.
Yeah, this is slow as shit.
It's compiling so much data.
Yeah, but who gives a shit if it runs transcritical? It's going to. It's all made up anyway.
How many algorithms this thing's probably running in order to run?
To
get all the right data?
It's made up data, just like all the made up money.
Monopoly money?
Yeah, the monopoly money. But no, I don't, the ejectors, I don't buy it for the complexity that they add to the rack. It's just, I don't see
complexity.
The control is a lot more.
All right, so let's calculate it now.
It's just so much more control. Guys struggle enough with what we have now, let alone throwing ejectors on there and multi-port ejectors.
So PSI head pressure. See, I don't know what 0.1 through 20 is. That's the other thing. Like I don't know what it's tracking here. Because you have a T value here, PSI all the way through, right? And then all of a sudden it shoots up to 223. So I don't know what.
We need to get some actual engineers on here.
Yeah. Should we get Yoey on here? Or
Is-
Bob? Oh, Bob's supposed to come back this week.
Bob or Joe doesn't work for you anymore.
Yeah, I know. Did I tell you when I saw Bob what happened? He was on an airplane. And so I joke around with Bob saying that he sounds like every bad guy villain ever. And so we're at the NASRC, and I was on the plane, and I was watching this movie called The Beekeeper, and the guy was South African, and he was the bad guy. And I looked, and I'm thinking to myself, do I really sound like that?
Yes.
Yes, you do. Yes, you do.
No,
But
this is cool. Like it's putting out the cooler capacity, total BTUs, low temp, throwing everything out there.
Yeah, the
We
intermediate.
lost the compressors.
Yeah, I just need to. I don't know why the ambient temperature is only 80. Because then I need to. Oh, that's right. Because I gave it an ambient number of 80. I didn't, because I wanted to make sure it was under capacity, because it kept yelling at me that I was over capacity. But I still need to figure out all this stuff. Let's see, because like you have, let's see, do constant. Called. Oh my God, there's so many options here. Supermarket low temperature, supermarket medium, cooling capacity. So I don't know. Evaporation temperature for constant profile. I need to read the damn manual. It's 80 pages and I haven't gotten to that point yet. Oh, I also forgot about this. So dry cooled, air cooled, evaporative condenser, cooling tower, water cooled, or hybrid. So if we do an adiabatic.
Oh, that's cool. It's nice to see some more sizing tools out of here. Does it do line sizing too or no?
What's this? Free cooling, 100% on when tap. Speed control. Oh, okay. All right. Suction side. Evaporation temperature. Dry. Because I thought there was a way to also do. I guess that's an open stage, 2-stage open intercooler. I don't know. I got to play around, because once you start changing this, it changes all the rest of the numbers here. So here you have as your here's your HPV, there's your BGV.
Yep.
But it also gives you your heat exchanger here from 14 to 1. So what I'm wondering is where that is. I'm assuming it would be somewhere over yonder. Right? And how much? Yeah, external heat exchanger efficiency, internal heat exchanger efficiency. So I guess that would be like how much energy you're going back and forth. We need to talk to Bob.
Tell you what, the heat exchangers on the drop legs absolutely suck. Especially if you're using it for like suction reheat. Oh man, is it terrible.
Why?
Because you just don't get that much. Especially if it's wintertime, you're SOL.
Okay, yeah, wintertime. Okay. All right.
Yeah, when it's wintertime, your flood back control is non-existent.
But
summertime, it's not as bad.
Yeah.
But wintertime, you might as well not even have it.
But look, as you start adding stuff, so look, this is a 2-stage liquid injection. So there you can figure out exactly how much capacity you would need based off of that if you wouldn't have the heat exchanger, right?
Really?
Yeah. And then you have 2-stage transcritical ejector with parallel compression. Then you have 2-stage. So what's cool, it gives you an actual readout of what, right? So I'd assume that a lot of these numbers would show up on the pH diagram.
Probably.
Right. And then 2-stage closed intercooler. Oh, okay. So this is what Carnot uses. Yes. Yes.
Yeah.
Yeah.
I don't know why it's showing the drawn inside of it like that, though. Because it makes it look like it's a line through there.
That it's feeding in.
Yeah, but see the black? It looks like it's one continuous line through.
I think that's another heat exchanger.
Oh.
You know what I mean? Where this is actually feeding directly into here.
Oh, I see now.
Yeah, this is just a separate heat exchanger.
Oh, so what the hell is going on here? No, that's what Carnot does.
Yeah. So there's that. Hold on, I wasn't done yet. Okay, so 2-stage open intercooler. So there's your open intercooler, right? So you're shooting literally discharge gas from the low temp. That's what that trainer does, the Emerson one, right?
Yep.
And then there's your 2-stage where it has a closed intercooler and I guess an open intercooler. So it's essentially doing both, right? And then you have 2-stage transcritical open. Holy crap. Yeah. So this basically encompasses almost
Everything we're doing.
Exactly. And that was part of the reason why
We're going to play around with it a lot more. It's
Yeah.
a good introduction. We'll start doing some sizing stuff. I want to start doing some breakdowns of like basic sizing and like checking compressors because we're getting a lot more remodel work. So this is going to be key. A lot of homework to do here.
Yeah. So here then we have CO2 cascade. So it looks like it's doing, oh yeah. So you can select different refrigerant for the primary, and then it's just CO2 for the secondary. And then you have, so that would be your Targets and your Walmart, or Targets, HEBs, right? And then you have cascade transcritical. So you basically have regular transcritical system here being the condenser for the low temp. So I guess you have a lower condensing temperature. And what's pretty freaking rad about this is, look, you can basically change it to flooded evaporators.
Huh.
Yeah. So you could actually see, okay, so what happens, how much more energy would I need to have in order to make a flooded evaporator? Is it to see if the actual
KW mark?
Yeah, and that's what I'm curious about, because we ask these questions all the time, and certain people have certain opinions about it. They're like, nah, it's scrap, doesn't work, it's not worth a shit. But is the information they're getting fallible because maybe the rack isn't tuned of what they're dealing with? So then you have a regular standard cascade.
No rack's ever tuned right for most of the time.
Stop it. So look, we can make an R600 rack running with no, we're not going to do 513. That's the devil. And then you have,
wow, was that a negative comment out of you about something?
134A with a shot of R1234XYZ something.
I have never had good luck with those racks, those 513A racks. Never.
Because like when they're coupled up with Cascade,
like instantly.
not just that, but 134A just like in comparison with BTU capacity sucks compared to something like CO2, right?
Yeah.
All right. So anyway, so you have 1-stage and then 2-stage common condenser. So basically a regular standard HFC booster. I guess you could make it CO2 as long as we running some of them are critical. And then you have 1-stage, which is, I'm assuming, just a regular standard system. 1-stage transcritical, 1-stage transcritical with ejectors, 1-stage transcritical with parallel compression.
It'd be medium temp only.
Yeah. And then 1-stage with the parallel compression, just running the flash tank. And the thing you don't like. The only thing that doesn't do, and once again, we'd have to get probably Bob on here. There's nothing on here that tells you about running hot gas.
Oh, for hot gas defrost?
Yeah, because I
don't think it's very common, to be honest to you, in Europe probably.
I don't know that. I know in industrial they're doing a shit ton of it. I know in some of the Schmambrons they're doing a lot of it.
It's all hot gas.
Costco as well. So what I'm wondering is, if anything, it's I don't think it's going to add any BTU. It's going to add components, but it actually, in all reality, probably lessens the load depending on where you're taking the gas from. Because no matter if you're taking the gas from the flash tank, you're lessening load on the medium temp compressors, right? If you're taking it from the hot gas side, you're lessening the load going to the gas cooler. So no matter what, you're mitigating one load to another because
rob Peter to pay Paul situation.
Yeah, you're creating that liquid and then deriving it back into the liquid
flash
side
tank.
or the flash tank. Yeah, so I don't think there's really any sizing things that have to be dealt with that. You'll probably on the evaporator side, right?
Valve sizing, that's about it.
Valve sizing and the pipe sizing. I don't know if there's any difference in CO2 for hot gas versus not.
So that's what I want to see is a decent sized line calculator. I've been using the Sporlan one on the old Sporlan software, It seems to be the only good, decent one. Other than that, like it'd be nice to get a sizing calculator because we run into that with some stores up here where we have to do the engineering for the line sizing, and it's always a pain.
You're talking just for standard CO2 or hot gas?
Both standard, or usually it's nothing smaller than a 1/2 inch on the liquid line for the hot gas stores. But I've also seen 7/8 liquid lines.
Wait, 7/8 liquid and what?
Like 7/8 suction, 7/8 liquid.
Oh,
some of the Carnot stuff. But
look what I just found.
what?
Oh, you're gonna be all excited now?
Find a line size calculator?
No, not yet. Look what it does have though.
What's that?
Groundwater engineering for it.
That's pretty cool.
Since you're on this big geothermal kick.
It's the way to keep it from going transcritical.
No, I get it. But what I'm saying is, I mean, look, pump, hot, cool.
That's pretty cool.
Yeah, so I guess you could size, yeah, because then you could size your, I don't know if you call it a heat pump then.
Technically, yeah.
I don't know. Oh,
Everything's a heat pump if you think about it.
I'm going to be up for hours now.
Oh, God.
This is awful.
I'm mentally drained just from this week and last week.
That's awful. All right, guys. Well,
yep.
See you
Hey, guys.
Go ahead.
Have a nice one, guys. Thanks for listening.
Bye, guys.